48. Structured data. Data that is highly organized and formatted in a table-like structure, rows and columns. Think of an Excel spreadsheet or a database table. It's easy for machine learning algorithms to process and analyze. Most traditional data analysis and ML is done on structured data. Examples include sales records, customer information, and financial data. 49. Unstructured data. Data that does not have a predefined model or organization. Think of text documents, images, videos, audio files, and social media posts. Over 80% of the world's data is unstructured. Deep learning techniques, CNNs, RNNs, are essential for analyzing this data. Extracting value from it requires more advanced NLP and computer vision tools. 50. Big data. Extremely large and complex datasets that cannot be managed with traditional tools. Characterized by the 3 versus volume, size, velocity, speed, and variety types. Requires specialized platforms like Hadoop and Spark for processing. AI and machine learning are the key tools for unlocking insights from big data. It's the fuel for today's most powerful deep learning models. 51. Data cleaning, pre-processing. The process of preparing raw data for use in a machine learning model. Involves handling missing values, correcting errors, and removing duplicates. Often cited as the most time-consuming part of a data science project. Garbage in, garbage out. Clean data is essential for a good model. Ensures the data is in a consistent and usable format for the algorithm. 52. Normalization, standardization. Scaling numerical features to a common range to prevent some from dominating others. Ensures features with large values, like salary, don't overpower those with small values, like age. Many ML algorithms perform better or converge faster with scaled data. Normalization scales to a range, 0, 1. Standardization scales to a mean of 0. A crucial step in data preprocessing for many models like SVMs and NNs. 53. API, Application Programming Interface, a way for different software programs to communicate with each other. How a mobile app gets weather data from a weather services server. Most AI models are deployed and made available to users via an API. Allows developers to integrate powerful AI capabilities into their own applications. You can use a translation API without knowing how the translation model works. 54. Cloud computing, using a network of remote servers hosted on the internet to store, manage, and process data. Provides on-demand access to massive computing power needed for training large AI models. Services like AWS, Google Cloud, and Azure are key players in the AI space. Eliminates the need for companies to own and maintain expensive hardware. Democratizes AI by making powerful tools accessible to everyone. 55. GPU, Graphics Processing Unit, a specialized electronic circuit designed to rapidly manipulate and alter memory for graphics. Their parallel structure makes them ideal for the calculations needed in deep learning. Training large neural networks can be hundreds of times faster on GPUs. The rise of deep learning is directly tied to the availability of powerful GPUs. Essential hardware for any serious work in deep learning or generative AI. 56. MLOps, Machine Learning Operations, the practice of deploying and maintaining machine learning models in production reliably. It brings software development discipline, DevOps, to the machine learning lifecycle. Focuses on automation, monitoring, and governance of AI models. Ensures that a model that works on a laptop also works at scale for millions of users. It's the last mile problem of AI, making models useful in the real world.